In this video, we will study how to get the roots of complex numbers. Now, by definition, if z is a complex number and n is a natural number, where n is greater than 1, then omega is an nth root of z. If omega raised to n is equal to z. Just like in the set of real numbers, for instance, if you have 16, the square root of 16 is 4, because when you square 4, the answer is 16. Or we know that the fourth root of 81 is either 3 or negative 3, because when you raise negative 3 or 3 to the fourth power, your answer is 81. And so for the set of complex numbers, it's the same definition. And we know for a fact that, for instance, if you have x cubed plus 8 equal to 0, or you have x to the fourth minus 81 is equal to 0, how many roots do we have for x cubed plus 8 equal to 0? Based on the degree, you have 3 roots. Also, for x to the fourth minus 81 equal to 0, you have 4 roots. Based on the degree. Now, likewise, if we want to solve for the value of x here, what we can do is just to solve for the value of x straightforward, no? X cubed equals negative 8, and then get the cube root of both sides of the equation. And so you have x equals the cube root of negative 8, that's negative 2. For x to the fourth minus 81 equal to 0, let's write it as x to the fourth equals 81. Getting the fourth root of both sides of the equation, you will have x equals 3 and negative 3. Now, ang tanong natin ngayon, nasaan napunta yung dalawa pang roots natin? Okay, so for x cubed plus 8 equal to 0, you only have one root here, x equals negative 2, a real root. And then for the x to the fourth minus 81 equal to 0, you have 2 real roots. Okay, pero kailangan natin dito, 3, and dito naman is 4. Okay, and so, we can think of the roots as being complex. Okay, pero it doesn't show dito sa solution natin ito. And so you have a general formula on how to solve for the roots of a given complex number in such a way na both the real, okay, and the complex roots of your given equation, okay, ay makukuha natin. Now, the form of that equation will be this one. You have omega sub k is equal to the nth root of r CJS theta plus k times 2 pi all over n, where r and theta are your modulus and argument respectively. So we are assuming here, like in getting the power of getting powers of complex numbers, no, when we use the Moivre's theorem, di ba, we need our complex number to be in polar form. Ganun din dito. When we use this formula to get the roots, kailangan naka-polar form yung complex number natin. Now, this form, okay, is, well, assuming na yung ating theta or yung argument natin ay naka-radians, no? But if your theta is in degree, then you can write this as omega sub k is equal to the nth root of r CJS theta plus k times 360 degrees over n. Now, your k here is from 0 to n minus 1. And so, if you are getting, for instance, fifth root, for example, fifth root of a complex number, then you have 5 distinct roots. Then you are getting omega sub 0, omega sub 1, 2, 3, up to omega sub 4. So, only up to omega sub n minus 1 because we start with k equal to 0. Now, omega sub 0 is what you call the principal root of your complex number. Okay, and so here, using this formula, okay, let's have some examples. Let's say you want to find all 4 roots of the complex number negative 8 square root of 3 plus j8. So, ang unang step natin is to draw first our complex number para madali natin siyang matransform into polar form. So, drawing natin siya nasa quadrant 2. Okay, so quadrant 2, you have here 8 square root of 3 units, and then you have 8 units along y. Now your argument is this, and so we need to solve for this angle alpha and relate it to your theta later on. So we first solve for the value of our modulus. R is equal to the square root of 8 square root of 3 squared plus 8 squared. So R is equal to the square root of 8 squared times 3 plus 8 squared. Now, instead of squaring and then adding the terms inside the radical, no, what I do is I just factor out the 8 squared. And so what will be left on the first term is 3, and then on the second term is 1, so 3 plus 1. So I will have the square root of 8 squared times 4. And then when I square the whole thing, you'll have 8 times 2, which gives us 16. And so our modulus is 16. Or you can just straightforward square 8, so 64 times 3, and then plus another 64, you'll get 256. And so the square root of 256 is still 16. Okay, now for the argument, theta, we first solve for the value of alpha here. Okay, so alpha is equal to arctangent 8 over 8 square root of 3. So cancel the 8, you'll have alpha equal to arctan 1 over square root of 3, or that will be alpha equal to pi over 6. So solving now for our theta, theta is equal to pi minus alpha because it's in the second quadrant, the terminal side. So theta is equal to pi minus pi over 6, or that will be 5 pi over 6. And so, negative 8 square root of 3 plus j8 can be written in polar form as 16 CJS 5 pi over 6. And so, we start here and get the roots. So, basically, what we want are the 4 roots of this complex number. And so, we want 16 CJS 5 pi over 6 raised to 1/4. So here, your R is 16, your theta is 5 pi over 6, and your N is equal to 4. Now recall again that our formula in finding the root will be omega sub k is equal to the nth root of R, CJS theta plus k times 2 pi all over N. So solving for the roots, we start with k equals 1. Starting with k equals 1, you have omega sub, k equals 0, You always start with k equals 0. So omega sub 0, the principal root, will be equal to the 4th root of 16, CJS, 5 pi over 6, plus 0 times 2 pi, all over 4. The 4th root of 16 is 2, and then you have CJS, you have 5 pi over 6 over 4, which simplifies to 2 CJS 5 pi over 24. So, multiply. When you simplify this, multiply ito 6 times 4. And so, you have 5 pi over 24. So, that's your first root. Okay. Now, for the second one, for k equals 1, omega sub 1 is equal to the 4th root of 16, CJS 5 pi over 6 plus 1 times 2 pi all over 4, which gives us 2 CJS 5 pi over 6 plus 2 pi I can write as 12 pi over 6 all over 4, and so you'll have 2 CJS, so 5 pi over 6 plus 12 pi over 6 is 17 pi over 6, and then over 4, then you'll have 17 pi over 24. So that's our second root. Now, for the third root, let's take k equals 2. So you have omega sub 2 equal to the fourth root of 16, CJS 5 pi over 6 plus 2 times 2 pi all over 4, which gives us 2 CJS 5 pi over 6 plus 4 pi is 24 pi over 6 all over 4, and so you have 2 CJS 5 pi plus 24 pi is 29 pi. 29 pi over 6 over 4, you have 29 pi over 24. And lastly, for k equals 3, omega sub 3 is equal to the fourth root of 16, CJS 5 pi over 6 plus 3 times 2 pi all over 4. So this is 2 CJS 5 pi over 6 plus 6 pi over 4, but 6 pi can be written as 36 pi over 6, di ba? 36 pi over 6. And so that's 5 plus 36. You have 41 pi over 6 over 4. So you have 2 CJS 41 pi over 24. And so the four roots that we have 2 CJS 5 pi over 24, 2 CJS 17 pi over 24, 29 pi over 24, and 2 CJS 41 pi over 24 are the fourth roots of your given complex number. Now let's have another one. Say you want to find all the roots of x cubed plus 8 equal to 0. Our example a while ago. Okay? So x cubed plus 8 is equal to 0. Therefore, what we want to get is basically x cubed equals negative 8. So we want x equals the cube root of 8. So the roots are x1, x2, x3, something like that. Okay, so x equals cube root of negative 8. Rather, cube root of negative 8. So for here, okay, our complex number for this problem, our complex number is basically your negative 8. So ang kinukuhanan natin ng root natin is the number negative 8. And so we first represent negative 8 in polar form, which is madali lang dapat. So what is negative 8 in polar form? Negative 8 looks like this. Okay, this is 8 units, and then you have your argument here to be pi. And so negative 8 is just 8 CJS pi. Right? So with this, we are getting 8 CJS pi raised to 1/3, where r is equal to 8, theta equals pi, and n equals 3. So solving for the roots, get k equals 0, omega sub 0 is equal to the cube root of 8 CJS pi plus 0 times 2 pi all over 3. And so you have here 2 CJS pi over 3. Now in this case, hindi kagaya nung kanina natin example na ang nakukuha natin na roots ay may argument na hindi special angle. Ito, special angle. So we can transform it readily to rectangular form. So let's transform to rectangular form our roots here. So your 2 CJS pi over 3 is simply 2 cosine pi over 3 plus j sine pi over 3, right? But cosine pi over 3 is just 1/2. and then sine pi over 3 is square root of 3 over 2. So technically, our first root is 1 plus j square root of 3. Now for our second root, k equals 1. So we solve for omega sub 1. That's cube root of 8 CJS pi plus 1 times 2 pi all over 3, which is simplified to 2 CJS 3 pi over 3, which is simply 2 CJS pi. But 2 CJS pi is just 2 cosine pi plus j sine pi. But sine of pi is just 0, and cosine of pi is negative 1. And so this is 2 times negative 1 or negative 2. Ito yung root na nakukuha natin kapag we just solve for x cubed plus 8 equals 0 and then x cubed equals negative 8, get the cube root of both sides. Ayan, makukuha natin yung real root na negative 2. Okay? And then lastly, for k equals 2, omega sub 2 is equal to cube root of 8 CJS pi plus 2 times 2 pi all over 3, which is 2 CJS 5 pi over 3. Okay, so what's 5 pi over 3? Okay, cosine and sine 5 pi over 3. Kasi ito ay 2 cosine 5 pi over 3 plus j sine 5 pi over 3. So, using reference angles, nasa ang quadrant ang ating 5 pi over 3. 5 pi over 3 is 2d minus 1, right? The numerator is twice denominator minus 1. Okay? So, nasa quadrant 4 ang 5 pi over 3. So, this is 5 pi over 3. Now, the reference angle is 2 pi minus 5 pi over 3 or simply pi over 3. So, this is the reference angle pi over 3. Therefore, your sine 5 pi over 3 is equal to sine pi over 3, and the cosine of 5 pi over 3 is equal to cosine of pi over 3. But since we are, or the terminal side of 5 pi over 3 is in the fourth quadrant, then cosine is positive, sine is negative. So this is negative square root of 3 over 2, and this is positive 1/2. Simplifying further, okay, our last root will just be 2 times 1/2 plus j negative square root of 3 over 2. Or you have 1 plus or 1 minus, you have 1 minus j square root of 3. And so say, let's draw the graph of this complex number. Okay, the previous example. Ano ba itsura ng graph niya kapag ginraph natin siya in one Argand plane or one complex plane? Okay, so sketch the graph. So our roots are the roots of x equals cube root of negative 8 are omega sub 0 equals 1 plus j square root of 3, omega sub 1 equals negative 2, and omega sub 2 equals 1 plus j or 1 minus j square root of 3. Now, tatansyahin lang natin yung graph dun sa Argand plane, no? Kasi may mga square root siya, no? Pero ang square root of 3 naman is around 1.7. No? So, square root of 3 is approximately 1.7 something. Okay? So, when you sketch, you can have your let's say this is 1, 2, 1, 2, negative 1, negative 2, negative 1, negative 2. So the first root is 1 plus j square root of 3. So we can put it somewhere, maybe here, the point here. Okay, so this is your 1 plus j square root of 3. And then the second root is negative 2. So you have here, this is your point, it's negative 2. And then for the third one, it's on the fourth quadrant. So let's say somewhere here. This is your 1 minus j square root of 3. And characteristic of this, kapag ginraph natin yung lahat ng roots ng isang complex number, whether it is for the fourth roots, the fifth roots, and so on, okay, what we will notice is that what we form is a circle. Well, this is not, obviously not a perfect circle, no? Pero when you connect the points, okay, connect these points here, okay, that corresponds to each of your complex number, what you form is a circle whose radius is the nth root of r. Kasi di ba, remember, dito, nung sinolve natin yan, yung polar form ng complex numbers natin, ng roots natin, lahat sila ay may modulus na 2. So this one, no, the graph that describes the roots of x equals cube root of negative 8 is a circle whose radius is 2. Okay, that's the cube root of r, or the cube root of 8. So ganun din sa problem number 1, pag ginraph natin yung apat na yon na roots, ang makukuha natin ay ang graph ay magfo-form din ng circle na ang radius ay kung ano man yung fourth root nung r natin dun sa problem na yun. Okay, so in general, let me just put this remark. Lastly, the points representing the n distinct roots of z equals our CJS theta are equally spaced points on the circle centered at the origin with radius of nth root of r.